Okay, so today we will solve few questions of this thermal stresses. The first question says a uniform slender cylindrical rod is made of homogeneous and isotropic material. The rod rests on a frictionless surface. The rod is heated uniformly if the radial and longitudinal thermal stresses are represented by sigma r and sigma z respectively. Then okay, so because the rod is resting on a frictionless surface and it is free to expand, so obviously the thermal stress developed will be equal to 0, as I have already told you that because thermal stress is developed always when there is some resistance while expanding. Okay, if the temperature of some substance is changed, it will definitely expand, but if we are resisting that expansion, then the stress which is developed is called as thermal stress. Okay, so if it is free to expand, obviously the thermal stress will be equal to 0, sigma r is equal to 0 and sigma z is equal to 0. Okay, next question. Okay, the steel rod of length L and diameter D fixed at both ends is uniformly heated to a temperature rise of del T. Okay, so we are having a steel rod which is having a length of L and diameter is D. Okay, it is fixed at both ends and it is heated to a temperature of del T. That means temperature changes del T. The Young's modulus is E and coefficient of linear expansion is alpha. The thermal stress in the rod is. Okay, so I have already told you thermal stress. What is the way to determine this thermal stress? How can we determine this thermal stress? So if it was free to expand, then how much expansion would it be? So it would have been L alpha T. Okay, but this wall is applying certain force and preventing this from expanding this much. So the role of this force is to compress this rod by an amount del L, where this del L is equal to PL by AE. Okay, this P is an axial force, it is getting it is applied on this particular rod, and the role of this P is to decrease this much expansion. L alpha T को कम करके रखना, del L को कम करके रखना. So this del L is nothing but PL by A. Okay, so from this geometry obviously we can conclude what this L alpha T is equal to del L, or you can say L alpha T is equal to PL by AE. Okay, now this P by A is nothing but stress. Okay, so you can write it as this LL will get cancelled out and you will get what? Stress sigma is equal to E alpha T. This is the direct formula for the stress if the rod is fixed rigidly between two ends. Okay, so directly you can write it as E alpha T. Answer is C. Okay, I just told you the process, otherwise you can directly write it as. Getting this? Okay, next question. Now, next question says a cantilever beam of tubular section consists of two material, copper as outer cylinder and steel as inner cylinder. It is subjected to a temperature rise of 20 degrees centigrade and alpha of copper is greater than alpha of steel. The stress developed in the tubes will be. Okay, so we are having a cantilever tubular section. It consists of two materials, copper is as an outer cylinder and steel as an inner cylinder. Okay, so we are having outer cylinder as copper and inner cylinder as steel. This is a steel and this is copper. Getting this? Okay, it is subjected to temperature rise of 20 degrees centigrade. The stress developed in the tubes will be. What will be the stress developed in the tube? Since alpha of copper is greater than alpha of steel, it is given. Okay, so if it was free to expand, as I already tell you that in order to determine thermal stress, best thing is to determine first if it was free to expand, then how much it would have expanded or how it would have expanded. Then when we are putting restriction on it, then what is the role of that restriction. Okay, simply अगर आप ये दो चीज़ कंपेयर करते हैं तो आप कोई भी थर्मल स्ट्रेस के क्वेश्चन सॉल्व कर सकते हैं. ओके, सो इफ इट वाज फ्री टू एक्सपेंड, अगर ये फ्रीली एक्सपेंड होता है कॉपर, तो ऑब्वियसली कॉपर का एक्सपेंशन ज़्यादा होगा. इफ इट वाज फ्री टू एक्सपेंड देन ऑब्वियसली कॉपर का एक्सपेंशन ज़्यादा होगा और स्टील का एक्सपेंशन कम होगा. Why? Because alpha of copper is greater than alpha of steel. Okay, so copper would have expanded more and steel would have expanded less. Okay, but क्या हो रहा है, दोनों को हमने join करके रखा है, तो दोनों both will stop somewhere here at this particular point. That means there is a compression in copper and there is tension in steel. Okay, so answer should be tension in steel and compression in copper. Answer should be B. Getting this now? Okay, next question. A square plate A cross A rigidly held at 3 edges is free to move along the 4th edge. If the temperature of the plate is raised by temperature T, then the free expansion at the 4th edge would be. Coefficient of thermal expansion is given alpha, modulus of elasticity is given as E, and Poisson's ratio is given as mu. Okay, so we are having a square plate having dimension A by A, which is rigidly held at 3 edges. Okay, so we will draw the square plate. Which is rigidly held at 3 edges like this. Okay. Now, the temperature of this plate is raised by T, then the free expansion in the 4th edge would be. So, free expansion 4th edge में किसके किसके कारण होगा? So, first thing, because this is free to expand along x axis means this is free to expand. Okay, so if it is free to expand, obviously the linear expansion would be L alpha t or A alpha t, because dimension is A, so it would have been A alpha t. This is A. Getting this? But इसमें एक lateral expansion भी होगा. Why? Because lateral direction में इसके expansion को रोका गया है, and that will apply certain force. Lateral direction में force लग रहा है, and because of this force, obviously it will expand a little more in the linear direction. Okay, and that lateral strain, as we know, is equal to mu into linear strain. This will be mu into linear strain. Okay, so this I should write it as this. First, del L is equal to A alpha t. Okay, so because of this linear strain, this will be equal to A alpha t divided by A will get cancelled out, and we will get linear strain as alpha into t. This is linear strain. Now, what will be lateral strain? So, as we know, lateral strain is what? Mu into linear strain. Okay, so it will be mu into alpha into t. Getting this? This is lateral strain. Now, total net strain in x direction. Net strain in x direction is equal to linear strain, which is alpha into t, plus lateral strain, which is mu alpha t. So, this will be equal to alpha into t into 1 plus mu. This is total strain in x direction. This is total strain in x direction. Now, what will be change in length in x direction? So, that will be total strain into length. Okay. So, total free expansion, therefore, free expansion is equal to, this will be equal to alpha t into 1 plus mu into length, which is a. So, this will be equal to A alpha t into 1 plus mu. Okay. So, the answer should be B, A alpha t into 1 plus mu. Getting this now? Okay. Next question. Okay. Now, this I have already told you in the theory part. A thin steel tire of diameter small d is to be shrunk onto slightly large wheel of diameter capital D. If E is modulus of elasticity of steel, the circumferential stress developed is. Okay, so circumferential stress I have already told you is capital D minus small d by small d into E, and that too will be tensile. Getting this on the steel. Next question. A steel bar is kept between two copper bars and rigidly connected at room temperature. If the system is fixed at both ends and cooled suddenly, the stresses produced in the bars will be. Okay, so now we are having a steel bar which is kept between two copper bars. Okay, so we are having a steel bar kept between two copper bars like this. This is a steel and this is copper bar. Okay. Now, this is rigidly connected at room temperature. If the system is fixed at the ends and cooled suddenly. Now, this system is fixed at the ends. इस system को fix कर दिया गया at the ends. Okay. Now, the stresses produced in the bar will be. Now, what will be the stresses produced? And this system is cooled suddenly. that means temperature of the system is decreasing. So if the temperature of the system is decreasing, what will be the stresses in both the bars? Okay, so just understand this thing very carefully, that this is fixed at both ends. Both bars are connected, कॉपर और स्टील को हमने कनेक्ट किया है, बट बोथ एंड से हमने फिक्स कर दिया है. ओके, सो सेम चीज़ हम करेंगे इफ द सपोर्ट वॉज नॉट देयर, इफ इट वॉज फ्री टू कंप्रेस. Okay, then how much would have been the compression? Okay, so if it was free to compress and if the temperature is decreasing, obviously copper would have compressed more and steel would have compressed less, because alpha of copper is greater than that of alpha of steel, as we know. So copper ज़्यादा उसकी लेंथ कम होती, स्टील की लेंथ कंपेरेटिवली कम होती. ओके, बट बिकॉज दोनों को हमने ज्वाइन करके रखा है, ओके, तो दोनों एक साथ कंप्रेस होगा like this. Okay, this is the case if there was not fixed support. अगर ये फिक्स सपोर्ट नहीं रहता, इफ इट वॉज अ कैंटिलीवर, जैसा कि हमने क्वेश्चन 1 में देखा या क्वेश्चन 2 में देखा, अगर ये कैंटिलीवर होता, अगर ये फिक्स नहीं रहता, तब ये यहाँ पर आता. बट बिकॉज दिस इज अ फिक्स सपोर्ट, देन ऑब्वियसली बोथ विल टेंड टू कंप्रेस, बोथ विल टेंड टू, दोनों की लेंथ जो है वो चेंज होगी, डिक्रीज होने की कोशिश करेगी. बट बिकॉज ऑफ दिस फिक्स सपोर्ट, ऑब्वियसली दिस विल होल्ड दिस कॉपर हियर एंड दिस विल होल्ड दिस स्टील हियर. दैट मीन्स दोनों में ही टेंसाइल स्ट्रेस लगेगी, इन कॉपर एज वेल एज इन स्टील, दोनों में टेंसाइल स्ट्रेस लगेगी. अगर ये नहीं होता, एज आई टोल्ड यू, अगर ये नहीं होता, अगर ये फिक्स सपोर्ट नहीं होता, देन ऑब्वियसली दोनों रेस्ट करते यहाँ पर, इधर रेस्ट करते दोनों, और कॉपर में टेंसाइल लगता है, स्टील में कंप्रेसिव लगता. ओके, बट बिकॉज एंड में फिक्स सपोर्ट है विच विल ट्राई टू होल्ड बोथ कॉपर एंड स्टील टुगेदर. ओके, तो ये फिक्स सपोर्ट का काम क्या है? ये फिक्स सपोर्ट का काम है कि कॉपर को भी अपनी तरफ खींच के रखना, स्टील को भी अपनी तरफ खींच के रखना. तो ऑब्वियसली कॉपर और स्टील दोनों में क्या होगा? टेंशन होगा. ओके, सो देयर विल बी अ टेंशन इन बोथ कॉपर एंड स्टील. Getting this not? Okay, next question. A metal bar of length 100 mm is inserted between two rigid support and its temperature is increased by 10 degrees centigrade. If alpha is given as 12 into 10 raised to power minus 6 per degree centigrade and Young's modulus is also given, we have to determine stress in the bar. Okay, so stress, as I have told you, is equal to E alpha T if it is rigidly fixed between two bars. So just put the value. E is 2 into 10 raised to power 5 into alpha is 12 into 10 raised to power minus 6 into change in temperature is 10 degrees centigrade. So from here this will be equal to 24 megapascal. Answer should be C. Getting this? Okay, next question. Determine the temperature rise necessary to induce buckling in a 1 meter long circular rod of diameter 40 mm shown in figure. Assume the rod to be pinned at its ends and the coefficient of thermal expansion is 20 into 10 raised to power minus 6 per degree centigrade. Assume uniform heating of the bar. Okay, what we have to determine is the temperature rise which is necessary to induce a buckling in a 1 meter long circular rod. Okay, कितना temperature rise इस rod में करेंगे? This is the rod given. इसमें हम obviously if we are increasing the temperature, this will tend to increase in length. Okay, इसकी length जो होगी वो increase होने की कोशिश करेगी, and because of that the length will tend to increase, and because of that there will be a compressive force because both ends are held at the ends, और वो लेंथ उसकी इंक्रीज होने की कोशिश करेगी, बट बोथ एंड्स आर होल्डिंग दैट स्टील रॉड, सो देयर विल बी अ कंप्रेसिव लोड. ओके, एंड दैट कंप्रेसिव लोड विल कीप ऑन इंक्रीजिंग. जैसे जैसे टेम्परेचर की वैल्यू इंक्रीज होगी वैसे वैसे इस कंप्रेसिव लोड की वैल्यू इंक्रीज होगी, and because of that compressive load after a certain point obviously there will be a buckling. When the compressive load will increase beyond a certain load, obviously there will be buckling. तो कितने टेम्परेचर इंक्रीज करने पर बकलिंग फिनोमिना होगा ये हमको बताना है. What should be the temperature rise in order that this rod should buckle? Getting this now? That means the load क्या निकालना है हमको? We have to determine this load जिसमें बकलिंग होगी. Okay, or you can say buckling होती है at Euler's buckling load as we know. Okay, so this Euler's buckling load we know is pi square by L square into EI. Okay, this is Euler's buckling load. ये वो लोड है जिस पर बकलिंग होती है. ओके, दैट मीन्स हमारा जो टेम्परेचर के कारण, टेम्परेचर चेंज के कारण जो थ्रस्ट लग रहा है P, दैट शुड बी इक्वल टू दिस मच यूलर्स बकलिंग लोड. गेटिंग दिस नॉट? ओके, और वो P की वैल्यू कितनी है? टोटल टेम्परेचर थ्रस्ट इज व्हाट? टोटल टेम्परेचर थ्रस्ट Okay, stress as we know is what, E alpha T, okay, and force is nothing but stress into area. So this force P, which is called as temperature thrust, will be equal to E alpha T into area. Getting this now? Okay, so just equate this. So this Euler's buckling load, pi square by L square into EI, this should be equal to E alpha T into area. Okay, so E will be cancelled out from here. Just put the value, we will get what? So this will be equal to pi square by L is 1000, 1 meter, 1000 mm into I is what? Pi by 64 into d dash power 4, 40 dash power 4. This is equal to alpha, which is 20 into 10 dash power minus 6 into temperature change, which we have to determine, into area. Okay, area is what? Pi by 4 into d square into 40 square. That's it. Okay, so from here only one unknown is there, which is temperature. So from here we can determine the value of this temperature T. This will be equal to 49.34 degree centigrade. Answer. Getting this not? Okay, so this is how we can solve this. We have to determine the buckling load. इसमें हमको buckling load निकालना है, तो हमने क्या किया, we know the formula for this buckling load, pi square by L square into EI, और total load जो लग रहा है that is E alpha T into A, हमने दोनों को equate कर दिया, and we got the value of temperature जिसमें buckling होगी. Getting this or not? Okay, next question. Okay, next question says a composite bar made of aluminum and steel is held between two rigid supports as shown in figure. They are stress free at 38 degrees centigrade. Initial temperature given is 38 degrees centigrade, at which this aluminum and steel is stress free. E of steel is given, E of aluminum is given, alpha of steel is given, alpha of aluminum is given, length दोनों की same है which is 1 meter, area of steel is given and area of aluminum is given. The temperature is increased to 58 degrees centigrade. Okay, so there is a difference between temperature is increased to 58 degrees centigrade and temperature is increased by 58 degrees centigrade. Okay, what is the difference? Initially the temperature is 38 degrees centigrade. Okay, this temperature is increased to 58 degrees centigrade, मतलब final temperature कितना हो गया 58 degrees centigrade. That means change in temperature कितना होगा 58 minus 38 which is 20 degrees centigrade. Okay, if it was कि अगर ये इस तरीके का होता है स्टेटमेंट दैट टेम्परेचर इज इंक्रीज बाय 58 डिग्री सेंटीग्रेड, मतलब सीधा सीधा डेल टी की वैल्यू वो दी रहती दैट इज 58 डिग्री सेंटीग्रेड. गेटिंग द डिफरेंस बिटवीन द टू. सो हियर डेल टी इज गिवन एज 20 डिग्री सेंटीग्रेड. गेटिंग दिस? ओके, नाउ द क्वेश्चन आस्क्ड इज the support reaction in kilonewton is. We have to determine the support reaction. Now what will be the support reaction? So same thing we can do if it was free to expand or contract. Okay, then what would have been the expansion? So if it was free to expand, then aluminum would have expanded by L alpha T of aluminum and steel would have expanded by L alpha T of steel. ओके, बट दोनों एंड से क्योंकि फिक्स है तो ये फिक्स पॉइंट क्या करेगा, इस पे लोड लगा के रखेगा विच विल ट्राई टू कंप्रेस दिस मच लेंथ del L of steel and del L of aluminum. Okay, so just by symmetry we know what, by geometry we know what, L alpha T of steel plus L alpha T of aluminum is equal to del L of steel plus del L of aluminum. So just put the value L alpha T of steel plus L alpha T of aluminum is equal to del L of steel plus del L of aluminum. Okay, length सबकी same है. Okay, so this will be L alpha T of steel plus L alpha T of aluminum is equal to PL by AE of steel plus PL by AE of aluminum. That's it. Okay, now because length is same, so length will be cancelled out. Okay, we have to determine the support reactions. That means P की value हमको निकालनी है. We want to determine the value of P. Okay, so just put all the values. So we will get what? So this will be equal to alpha of steel and alpha of aluminum is given. Alpha of steel is 11 into 10 raised power minus 6 and alpha of aluminum is 24 into 10 raised power minus 6. So this will be equal to 11 plus 24 into 10 raised power minus 6 into temperature change is given as 20 degree centigrade. okay, is equal to P, which will be taken as common. Now here it will be 1 by AE of steel. Area of steel is 100, E of steel is 200 gigapascal. उसको भी न्यूटन पर mm स्क्वायर में करना है, तो इंटू 200 इंटू 10⁻3. ओके, कन्वर्ट एवरीथिंग इंटू न्यूटन पर mm स्क्वायर विच इज मेगा पास्कल. ओके, सो गीगा पास्कल को मेगा पास्कल में कन्वर्ट करने के लिए 200 इंटू 10⁻3. ओके, सो दिस विल बी प्लस 1 डिवाइडेड बाय एरिया ऑफ एल्यूमिनियम इज 200 इंटू ई ऑफ एल्यूमिनियम इज 70 इंटू 10⁻3. Getting this? So from here this P will be equal to 5.76 kilonewton. Answer. So P will be 5.76 kilonewton. Clear or not? Okay. Now next इसी का सेकेंड पार्ट है. वी हैव टू डिटरमाइन द स्ट्रेसेस इन स्टील एंड एल्यूमिनियम. ओके, तो फोर्स तो मिल गया हमको. स्टील और एल्यूमिनियम पे फोर्स कितना लग रहा है? दैट इज 5.76 kilonewton. Just divided by area we will get stress. Okay, so stress of steel will be equal to 5.76 into 10⁻3 डिवाइडेड बाई एरिया ऑफ स्टील विच इज़ 100 mm स्क्वायर में. तो ये न्यूटन पर mm स्क्वायर में मेगा पास्कल में आएगा डायरेक्टली 57.65 मेगा पास्कल. गेटिंग दिस? सिमिलरली सिग्मा ऑफ एल्यूमिनियम इज 5.76 इंटू 10⁻3 डिवाइडेड बाई 200. सो दिस विल बी इक्वल टू 28.82 मेगा पास्कल. ओके, सो आंसर इज 57.65 एंड 28.82 मेगा पास्कल. Clear or not? Okay, next question is a common data question, linked question, sorry. A gunmetal rod of cross section area 200 mm square is screwed at ends, passes through a steel tube of cross section area 100 mm square. Okay, so we have a gunmetal rod which is passing through the steel tube. The nuts on the rods are screwed tightly home on the ends of the tube. The temperature is decreased by 200 Fahrenheit. ES is given, E of gunmetal is given, alpha S is given, alpha of gunmetal is given, and length of both are same. Okay, so we are having a gunmetal rod. This is the gunmetal. Okay, this is screwed on the steel tube. Okay, so this outer tube is a steel tube. This is a tube. Okay, अगर मैं इसका cross section दिखाऊँ, it would be like this. Getting this? Okay, so this would be the cross section area. That means एक steel की tube है and inside there is a gunmetal. Okay, now the temperature thrust we have to calculate. The nuts are tightly screwed on the tightly on the ends of the tube. Temperature is decreased by 200 Fahrenheit. 200 Fahrenheit से temperature उसका decrease हो रहा है. Then the temperature thrust due to composite action would be. What would be the temperature thrust now? सो टेम्परेचर अगर डिक्रीज़ हो रहा है, ऑब्वियसली अगर दोनों को हम टाइटन नहीं करते, दोनों को जॉइन नहीं करते हैं, देन ऑब्वियसली गन मेटल वुड हैव कंप्रेस्ड मोर एज कम्पेयर टू स्टील. वाई? बिकॉज अल्फा ऑफ गन मेटल इज़ मोर एंड अल्फा ऑफ स्टील इज़ लेस. ओके, तो अगर इसको हम टाइटन नहीं करते हैं एंड्स में, तो स्टील कंप्रेस होता सपोज इतना, गन मेटल वुड हैव कंप्रेस्ड मोर, लेट सपोज दिस मच. Okay, where this length is nothing but L alpha T of steel and this length is nothing but L alpha T of gunmetal. Okay, but क्योंकि दोनों को हमने tightly held करके रखा है बीच में, then obviously दोनों की जो final position होगी that would be this. Okay, and because there is a final position, so obviously there will be a compression in the steel. Steel में compression होगा और गन मेटल में टेंशन होगा. ओके, एंड दिस दोनों का फोर्स जो है वो सेम रहेगा. पी फोर्स विल बी सेम, और इस पी फोर्स का काम रहेगा स्टील में डेल एल लेंथ को कम करके रखना, डेल एल वन को, और गन मेटल में डेल एल टू लेंथ को बढ़ा के रखना. गेटिंग इट नॉट? ओके, तो यहाँ अगर हम ज्योमेट्री से देखें, देन इट वुड बी L alpha T of gunmetal minus L alpha T of steel. Okay, L alpha T of gunmetal, this is total L alpha T of gunmetal, minus L alpha T of steel, this will be equal to del L1 plus del L2. Getting this or not? Okay, so this will be equal to del L1 plus del L2. Getting this? Okay, so just put the value. So this will be equal to, length is same, you can cancel out the length. Okay, this will be del L1 is nothing but P1 PL by AE of steel plus PL by AE of gunmetal. Okay, this is L alpha T of gunmetal minus L alpha T of steel. Okay, so from here you can cancel out the length cancel हो जाएगी. You have to calculate the value P की value निकालनी है. So just put the value. So this will be equal to T is 200 Fahrenheit into alpha of gunmetal 10 minus alpha of steel 6 into 10 raised power minus 6 taken as common is equal to P 1 by AE of steel. So area 100 into 200 into 10 raised power 3 E plus 1 by AE of gunmetal 200 into 100 into 10 raised power 3. Getting this amount? Okay, so from here only one unknown is there, which is P. So from here you can calculate the value of this P, which is equal to 8000 Newton or 8 kilonewton. Getting this or not? Okay, next, the temperature stresses in the steel and gunmetal respectively. So this as I told you, this was a linked question. So a force मिल गया है. Now we have to determine the stress, temperature stress. Okay, so this sigma steel will be equal to force upon area. So force is 8000 divided by area of steel is 100. So this will be equal to 80 megapascal. Okay, similarly sigma aluminium is equal to 8000 divided by area is 200. So this will be equal to 40 megapascal. Okay, so answer is 80 megapascal and 40 megapascal B. Clear or not? Okay, next question. Okay, next question says a rigid block weighing 60 kilonewton is supported by 3 rods symmetrically placed as shown in figure. The lower end of the rod are assumed to have been at the same level. Lower end is at the same level before the block is attached. The cross section of the rods and modulus of elasticity of the materials are given as ES is given, E brass is given, area of steel is given, area of brass is given, lengths are given. Length of steel is 0.5 meter and length of brass is 1 meter. Okay, now what we have to do is first we have to determine the stresses in the steel rod. Okay, first thing is to determine the stress in the steel rod. Now how can we determine the stress? So one thing is given that the wires are at the same level before the block is attached. Okay, so when these wires are obviously at the same level before the block is attached, and after this block is attached, now because दोनों साइड में स्टील है यहाँ पर और बीच में यहाँ ब्रास है, तो ऑब्वियसली दोनों का डिफ्लेक्शन जो फाइनल पोजीशन होगी इस ब्लॉक की डेट वुड बी लाइक दिस. दैट मीन्स दोनों का डिफ्लेक्शन होगा स्टील का और जो ब्रास का डिफ्लेक्शन है डेट विल बी सेम. Getting this? That means del L of steel should be equal to del L of brass. Okay, why is this happening? Because दोनों एंड से स्टील ने सपोर्ट करके रखा है इसको, सो दोनों का डिफ्लेक्शन सेम होगा. Getting this? और यू कैन से what is del L? PL by AE or sigma into L by E. So sigma L by E for steel, this should be equal to sigma L by E for brass. Okay, so just put the value. Okay, so for steel this will be equal to sigma into length of steel is 0.5 divided by E of steel 210 gigapascal is equal to sigma of brass, this is sigma of steel, into length of brass is 1 divided by 98. Okay, so from here you will get one relation which is sigma brass is equal to 0.23 of sigma steel. This is the first relation between sigma steel and sigma brass, first thing. Okay, now what will happen if I draw the free body diagram of this block? Okay, so the downward load of 60 kilonewton is acting. Okay, and here we are having P brass, then P steel and P steel like this. Okay, so you can write it as, for equilibrium, P brass plus 2 times of P steel, this should be equal to 60 kilonewton. Okay, or you can say sigma B into AB, P can be written as sigma into A, plus 2 times of sigma S into AS, this is equal to 60 into 10 raised power 3 in terms of Newton. Okay, so just put the value और relation भी रख सकते हैं इसमें. sigma B is equal to 0.23 of sigma brass. Okay, so just put the value, this will be equal to sigma B is 0.23 sigma steel into area 10 into 10 raised power minus 6 plus 2 into sigma steel into area which is 5 into 10 raised power minus 4. Getting this? This is equal to 60 kilonewton. Okay, so from here we can determine the value of the sigma steel. So this sigma steel from here will be equal to 48.7 megapascal, and if you put the value sigma brass is equal to 0.23 of sigma steel, so this will be equal to 11.2 megapascal. Answer. Okay, so answer should be, we want to determine the stress in steel, so stress in steel is equal to 48.7 megapascal. Answer. Okay, next question says if the coefficient of thermal expansion for steel and bronze are 11 into 10 raised power minus 6 and 19 into 10 raised power minus 6 per degree centigrade respectively, the temperature rise in degree centigrade to cause all the applied load to be supported by the steel rod is. Okay, now the coefficient of expansion is given. This is continued from the previous question, common data question was the. So coefficient of expansion अब दे दिया है, alpha of bronze दे दिया है, alpha of steel दे दिया है. Now we have to tell the minimum temperature rise which is necessary such that whole load should be supported by steel rod. Now how is it possible? Just understand this question very carefully कि किस तरीके से ये possible है. Now as we know that alpha of bronze is more, alpha of steel is 11 and alpha of bronze is 19 into 10 raised power minus 6. That means alpha of bronze is more as compared to alpha of steel. Now what does this mean? This means that if it was free to expand, अगर ये freely expand होता तो ब्रॉन्ज ऑब्वियसली ज़्यादा एक्सपेंड होता, स्टील कंपेरेटिवली कम एक्सपेंड होता इफ़ इट वॉज फ्री टू एक्सपेंड, बट इट इज़ नॉट फ्रीली एक्सपेंडिंग. एंड में क्या लगा हुआ है? एक लोड लगा हुआ है 60 किलो न्यूटन का. सो दिस इज़ नॉट फ्रीली एक्सपेंडिंग. दिस इज़ बाउंड टू डिफ्लेक्ट इन द सेम रेट. दोनों एक साथ डिफ्लेक्ट हो रहा है. Now but still, because if the temperature is increasing, since bronze will tend to expand more as compared to that of steel, और both ends से steel से connected है, then what will happen after a certain limit? Okay, after a certain limit, this bronze wire will tend to buckle. Okay, this bronze wire will tend to buckle like this. Okay, एक पर्टिकुलर लिमिट के बाद क्या होगा? ये ब्रॉन्ज वायर जो है ये बक्कल होना शुरू करेगा. वाई? बिकॉज दिस टेंड्स टू एक्सपेंड मोर. इसका अल्फा ज़्यादा है एज कम्पेयर टू डेट ऑफ स्टील. इफ आई एम इंक्रीजिंग द टेम्परेचर, ब्रॉन्ज वायर टेंड्स टू एक्सपेंड मोर एज कम्पेयर टू स्टील, बट बोथ एंड से क्योंकि स्टील ने कनेक्ट करके रखा है तो ये एक पॉइंट के बाद बकल होना शुरू होगा. और जिस पॉइंट पे वो बकल होना शुरू होगा, एट दैट पर्टिकुलर पॉइंट दिस 60 किलो न्यूटन, होल ऑफ दिस 60 किलो न्यूटन विल बी सपोर्टेड बाय द स्टील रॉड्स ओनली. ओके, जहाँ वो बकल हुआ डेट मीन्स पूरा जो 60 किलो न्यूटन का लोड है वो पूरी तरह से किस में आ जाएगा? स्टील के रॉड्स में आ जाएगा. गेटिंग दिस नॉट? ओके, नाउ गेटिंग दिस. सो हमको वही पॉइंट निकालना है कि किस पॉइंट पे वो बकलिंग उसकी शुरू होगी सच दैट कि पूरा जो लोड है वो स्टील में आ जाएगा. एंड वंस दैट हैपेंस, पूरा लोड अगर स्टील में आ गया, देन व्हाट विल हैपन? देन टोटल एक्सपेंशन जो हो रहा है, the total expansion of bronze, that means L alpha T of bronze, okay, because the bronze is expanding just because of temperature change T. Okay, because इसमें अब कोई लोड नहीं लग रहा है, but स्टील में स्टील is supporting this 60 किलो न्यूटन of load. Okay, so a total expansion of steel is equal to L alpha T of steel because of temperature change plus because of the load of 60 किलो न्यूटन. Okay, ब्रॉन्ज का सिर्फ और सिर्फ टेम्परेचर चेंज के कारण होगा बिकॉज उसने लोड छोड़ चुका है. स्टील का टेम्परेचर चेंज के कारण तो होगा ही साथ लोड के कारण भी होगा, 60 किलो न्यूटन लोड के कारण होगा. और दोनों का एक्सपेंशन, बिकॉज नीचे हमने ब्लॉक लगा के रखा है, दोनों का एक्सपेंशन सेम होगा. दोनों का जो डिफ्लेक्शन है, डिफ्लेक्शन बोलना चाहिए नॉट एक्सपेंशन, दोनों का डिफ्लेक्शन सेम होगा. देयरफॉर एल अल्फा टी ऑफ ब्रॉन्ज इज इक्वल टू एल अल्फा टी ऑफ स्टील प्लस पी एल बाई ए ऑफ स्टील. ओके, सो दिस कैन बी रिटन एज व्हाट? एल अल्फा टी ऑफ ब्रास minus L alpha T of steel is equal to PL by AE of steel. That's it. Okay, now just put the values. Now length of brass is 1 meter, alpha of brass is 19 into 10 raised power minus 6 minus L of steel is 0.5, alpha of steel is 11 into 10 raised power minus 6. T will be taken as common. This is equal to PL by AE. Okay, P is how much total load we are taking here as total load as 60 kilo Newton, which is distributed among two steel rod. So if I am taking 60 kilo Newton, I will have to take area of both steel rod combined. और अगर मैं एक स्टील रॉड के लिए ले रहा हूँ देन लोड भी उसमें 30 किलो न्यूटन होगा और एरिया भी उसमें सिंगल स्टील रॉड का होगा. गेटिंग दिस. सो आई एम टेकिंग दिस टोटल लोड एज 60 किलो न्यूटन एंड एरिया भी हम उसमें दोनों स्टील रॉड का ले लेंगे. सो दिस विल बी इक्वल टू 60 इंटू 10⁻³ okay into 0.5 length of steel divided by area 2 times of 5 into 10⁻⁴ into E is 210 into 10⁻⁹. Getting this? Okay. So from here we can determine the value of this T, which is equal to 10.58 degree centigrade. Okay. So answer should be 10.58 degree centigrade B. Clear or not? Okay. Next question. Okay. This question says, if the rod fitted snugly between the supports as shown in the figure is heated, the stress induced in it due to 20 degree centigrade rise in temperature would be. Okay. So we are having a rod which is fitted along with the spring. K of spring is given, alpha is given as 12.5 into 10⁻⁶, E is given. Okay. Diameter of rod is given as 10 mm and length of rod is 0.5 meter. Okay. So when if we are increasing the temperature by 20 degree centigrade, what will be the stress induced in the rod? Okay. Now let us first understand कि stress rod में आखिर होगी क्यों. Now because if the temperature is increased by 20 degree centigrade, so this rod will tend to expand. Because temperature is increasing by 20 degree centigrade, this rod will tend to expand, this will expand, and because of this spring will compress. Okay. And because the spring में deflection हो रहा है, then it will put certain force on this rod, and because of this force stress will be developed. So वो stress कितनी होगी ये हमको निकालनी है. Getting this or not? Okay. So for that first we will have to calculate that force कि वो force कितना लग रहा है, then by dividing it by area we can calculate the stress. Okay. Now how can we determine? So for calculating force, first we can calculate del L, total change in length. This change in length is nothing but L alpha T. Getting this? Because of change in temperature, total change in length is L alpha T. Okay. This L total length is 0.5 into alpha is 12.5 into 10⁻⁶ into T is 20 degree centigrade. So from here this del L is equal to 1.25 into 10⁻⁴ meter. Okay. This is total change in length. Now we know what K spring constant is equal to force per unit deflection. Okay. Or you can say total force is equal to K into del L. Okay. Now the value of this K is given, so we can calculate the value of force. So this force will be equal to K, which is given as 1.25 K is given as 50 kilonewton per meter. Okay. Into kilonewton per meter means into 10⁻³ into del L is 1.25 into 10⁻⁴. Getting this? So from here this force will be equal to 6.25 Newton. Now once you have determined the value of this force, now it is easy to determine stress. Stress is equal to force per unit area. So this will be equal to 6.25 divided by area is pi by 4 into d square, 10 square. So this will be equal to 0.0795 megapascal, and that too compressive in nature. Why compressive? Because the force acting here is compressive in nature, so the stress will be compressive. Okay. So answer should be B minus 0.0795 megapascal. That's it. Okay. Next question says a solid steel cube constrained on all 6 faces is heated so that the temperature rises uniformly by del T. If the thermal coefficient of material is alpha, Young's modulus is E, and Poisson's ratio is mu, the thermal stress developed in the cube due to heating is. Okay. So what it is said in the question, we are having a solid steel cube which is constrained from all the 6 faces. Okay. So first I will draw the solid steel cube. Constrained from all faces. Okay. And now it is subjected to it is constrained from all the faces, and the temperature is now increased. So what will happen when the temperature of this solid cube increases? Because this is constrained from all the faces, this is packed from all the faces. So when the temperature increases, it will tend to expand, but because that is constrained from all the ends, so it will, the supports will apply the force on all the ends. Okay, so I will draw the force. Okay, so these are the forces acting at all the ends, and this force magnitude will be equal, will be same. Let's suppose that is P, and let's suppose the stress developed is sigma. Getting this? Okay. Now, what it is said, we have to determine the thermal stress developed in the cube due to heating. We have to determine the thermal stress. Now, how can we determine this thermal stress? So, same thing we have to do as I have told you. Whenever we want to solve the question of thermal stress, what we have to do is we have to assume that if it is free to expand, then how much it would have expanded. So, if this solid cube is free to expand, then obviously in any direction you can take, we are taking in x direction, then let us suppose in x direction it would have expanded by an amount L alpha T. Okay, that means strain in x direction, thermal strain in x direction will be equal to L alpha T. Okay, but in actual case it is not expanding, it is constrained from all the directions, and because of that constraint it is applying a force P from all the ends, or the stress sigma from all the ends, and because of which there will be the mechanical strain, and magnitude of that mechanical strain as we know will be equal to minus sigma x upon E. Because of sigma x there will be a linear strain in x direction, and because of sigma y and sigma z there will be lateral strain. So, plus mu into sigma y by E plus mu into sigma z by E. Why minus sigma x? Because it is compressive in nature. Okay, now what we have to do is we have to equate this two. Okay, it would have expanded by this much, but the force is preventing this much, that means this two will be equated. Getting this or not? That means sorry, this is thermal strain, this L alpha T is del L, we have to divide it by L and then we will get the thermal strain. Okay, so when dividing by L we will get just alpha T, not L alpha T. Okay, so we will equate this two. Okay, and we will get what? So, from here this alpha into T is equal to minus sigma x by E plus mu sigma y by E plus mu sigma z by E. Getting this? Now, because forces are same, so stresses will be same, sigma x, and area is also same because that is a cube. Sigma x is equal to sigma y is equal to sigma z is equal to sigma. So, we can say what? Alpha into T, where T is change in temperature, you can write it as del T is equal to minus sigma upon E into 1 minus 2 mu. Getting this? Okay. So, from here this sigma will be equal to minus E alpha T divided by 1 minus 2 mu. Answer. Okay, so this is our answer, E alpha T minus E alpha T into 1 minus 2 mu. Answer should be A. Getting this or not?